Hi everyone. In lesson 26, we're going to talk about a variety of distributions that were going to help us construct confidence intervals next week. Now we've already met the standard normal Z distribution, and we're going to talk about other distributions, the T distribution, and the T distributions, plural, and the chi-squared distributions, plural. But there is only one standard normal Z distribution. I should have said the standard normal Z distribution, although it inspired us to generalize this to other normal distributions. But we're going to compare and contrast the Z distribution with the T and chi-square distributions that we'll discuss later on. So let's review the standard normal Z distribution. All right, so this is the normal distribution. We're reminded of this bell-shaped density curve. This distribution has mean 0, no units, mean 0, and standard deviation 1 unit. And what were some properties, some other properties of the standard normal distribution, what I call the Z distribution? Well, they're continuous. In fact, all of these distributions will be continuous. The Z, the T's, and the chi-squared, they will all be continuous. So we're going to have density curves for all of these. A normal random variable, including the Z, can take on any real number as a value. The density curve is bell-shaped, as the T's will be. The total area under the density curve and above the Z-axis is 1. Well, that's true for any probability density curve. The area between the curve and the horizontal axis will always be 1, because 1 is always total probability. Remember, the 1 up here corresponds to the standard deviation being 1. The 1 here means that the area under the curve is 1. They're different ideas. Again, the mean of the Z distribution is 0. The center is 0. The density curve is symmetric about the mean. So we have mirror images to the right and to the left. And the standard deviation is 1. Again, visually, the standard deviation, I'll try to do this better. So the mean is 0. The standard deviation is 1. And although you don't really have to know this for this class, it's nice to know this for drawing good pictures. But the standard deviation is the distance between the mean line, the 0 here, and by the way, mu is 0, the mean. Sigma, the standard deviation, is 1. We use population parameter notation for distribution parameters. The distance between the mean line and either inflection point, that's the standard deviation. This normal bell curve has 2 inflection points, one over here and one over here. They're symmetric about the mean line. You learn about inflection points in calculus. These points are where the graph changes concavity, kind of like curvature, from concave down to concave up, or vice versa. The picture down here may be more helpful. This is from Mathematica. So here is the Z distribution. Here's the probability density curve for the standard normal Z distribution. The mean line is at 0. Again, no units. The standard deviation is 1 unit. No particular unit like feet or miles. These are 2 inflection points. Again, the standard deviation is the distance between the mean line and either inflection point. Again, that's nice to draw good pictures, but you don't have to know that. More generally, for a general normal distribution, the mean does not have to be at 0. The standard deviation does not have to be 1, although it does have to be positive. Okay, but those are for general normal distributions. The Z is the star of the show. The key normal distribution we're going to deal with is the Z distribution, the standard normal. So that was a review of the standard normal Z distribution. We're going to explain and discuss similarities and differences between the Z distribution the t distributions and the chi-square distributions later on.